lot of those identities, these are going to be the only three that we haven't talked about yet, okay? And my purpose of going through these sort of early with you here is the last 2 weeks or last 3 weeks of school here, you're going to have to know these identities like the back of your hand, okay? So you're not going to be able to, keep up in class or to be able to do your work in a timely manner if you don't know all these, okay? Now, your Pythagorean identities, they come from what it sounds like. They come from the Pythagorean theorem, okay? Now, the first one here, now this is the only one that I actually have memorized. The other two, I'm going to show you how to derive, okay? But it's first one, the most common one is this one, is sine squared theta plus cosine squared theta equals 1. So you can kind of see that comes off of from the Pythagorean theorem, and I'm going to use my unit circle here because my unit circle has a radius of 1. Okay, and that radius is the hypotenuse of that triangle. Okay, that's the main Pythagorean theorem, or Pythagorean identity you should know. Okay, now the other two, even after I've taught trig for 100 years, I can't memorize the other two. Okay, and the reason why is somebody taught me how to derive the other two, so I didn't put the effort into it. Okay, so I'm going to do this. For the second one, I'm going to start off with the first one and just modify it. And this way I don't have to memorize. Because you got to memorize so much in trig anyway. Okay, now what I'm going to do to this one, okay, I'm going to take that first one and I'm going to divide both sides here by cosine squared theta. Okay, so if I can remember to do just this, then I can remember the second and the third one. Now, so let's do that. I'm going to go through, I'm going to divide by cosine squared. Okay, now you should be able to tell me what this is going to give me when I do this. All right, so what's that first thing going to give me there? Tangent. Okay, now it's not just going to be tangent theta. It would be, yeah, right, tangent squared. Okay, so we get tangent squared theta, right, plus 1, because that's the same thing, isn't it? Okay, something over itself is 1. And now, what's 1 over cosine? Secant, all right? But 1 over cosine squared would just make it secant squared. Okay, that's your second. And there again, I never remember this one. I can't remember it for nothing. Okay, so when I do these, I always just have to derive that second one. I went through and I divided, see my first one right there? I went through and I divided each term by cosine squared. Because the reciprocal of cosine is secant. Okay, my reciprocal identities. All right. Now, for the third one, I'm still going to start off with the first one, and you may be able to figure out how to derive the third one by now. That's it. Okay. Did y'all hear? Did y'all figure it out? You just divide by sine squared. All right, so let me do that. Let me divide everything by sine squared. Let's see if you guys can tell me. All right, that's 1. Right, cosine over sine is cotangent, so this would be cotangent squared. And then 1 over sine, cosecant. This would be cosecant squared. Okay, that's my third one. Okay, so these are the 3 that I have to know. Okay, you have to know this one without hesitation. Okay, and then the other 2, you can always derive them. You don't really have to know them as well. Okay, but if you know the first one, you'll know the second and third. Okay, now you're not going to see the use of this. And the reason why you don't see the use, you know how we draw triangles all the time to find our ratios? These are alternatives to drawing the triangles. What you could do, like if we have the sine ratio, You know how we draw the triangle and find the other ratios? The other way that you could do it is to plug into this and find the cosine ratio. Okay, but that takes too long. It's really easier and more visual to draw triangles, but we're going to have to use these eventually. Now, the rest of these is just going to be old stuff. Sure. All right. So let's see if you know these. All right. Now you may not know them by the name. Okay. The quotient identities. All right. But if I gave you the first thing, you can give me the second thing. Okay. All right. So this part, we use this one like every day almost, don't we? Sine over cosine is tangent. Okay. All right. And so we probably already know that. But again, this is a lot of this stuff you're going to have to know without hesitating. Okay. And it's going to be hard to keep up with what we're going to do the next 2 weeks if we don't know these real well. All right. So we probably know this one too. Cosine over sine is what? Cotangent. Okay. Reciprocal of tangent. Now, that leads me to these. All right, your reciprocal identities. Okay. Before I uncover them, see if you guys can tell me what are the reciprocal functions. So if I have like sine 1 over, what's our reciprocal for sine? Cosecant. Okay, so sine is 1 over cosecant, and then cosine is 1 over secant, and then tangent is 1 over cotangent. All right, and then we could just say all those backwards. So if I had cosecant, then the reciprocal would be 1 over sine. Okay, if I had secant, then it would be 1 over cosine. And if I had tangent, it would be 1 over cotangent. Okay, there again, we should know all those. I got them out of order a little bit. Order is not really important. I probably should have swapped those two, but the order that we know them doesn't matter. The thing is what we know. And really, what's going to be really important with these probably are those first two, because that's what we're going to use. Eventually, we're going to get to a strategy, and the strategy says that we're going to write everything in terms of sine and cosine. So if I have tangent, I can write it like that. I can write it in terms of sine and cosine. Same thing with cotangent. But if I have cosecant and secant, I can write them like that. And so everything can be written in terms of sine and cosine. That's why I need to know all that. All right, let's see if we know these. All right, our even and odd trig functions. Which ones are even? Right, cosine and secant are even. And so that's all we really need to remember. And we can just remember that the other four are the odd ones. Okay, so you got cosine and secant are even, and then the other four are odd. All right, now let's look at the application of it though. Okay, so what if I try to find the cosine or the secant of a negative angle? Right, right. So cosine of negative theta would just be cosine theta. Okay, and secant of negative theta is just secant theta. And so, I don't necessarily memorize this as much, okay, as I memorize that cosine and secant are even. Okay, and that's all I got to remember out of my even and odd stuff. The other stuff just should kind of make sense here. So now, on the other four, it's going to happen when we take one of those functions of a negative angle. Right, the negative just moves out front. I got those. Now, am I right about the fact that we should know these pretty well anyway? Okay, with the exception of Pythagorean identities. Okay, are y'all recalling these okay? All right. Shouldn't be that hard then to just reproduce this on the test Tuesdays. That's all I'm going to do is just ask you straight out. Okay, what are my reciprocal identities? Okay, what are my Pythagorean identities? What are my quotient identities? Okay, all right, let's look at these. I guess you could call them periodic properties, or your periodic identities. Okay, now look at your root word there, and you'll figure them out. What's our root word there? Period. Okay, so let's see. What do we know? This. I'm thinking about the graphs more so than the unit circle. Right. Most of the time, the period was 2 pi. All right. It was pi on tangent and cotangent, but it was 2 pi on the rest of them. So on all these, your period was just 2 pi, and then on tangent and cotangent, it was just pi. We probably know those pretty good. Now, let's look at sort of the application of these, okay? And I'm going to just do this. I'm going to do it. I want you guys to kind of do it backwards from what I do. All right. Now, let's take in what I've got written on the right-hand side. Okay, so I've got the sine, the cosine, the cosecant, and the secant of some angle x plus or minus 2 pi k. Now, 2 pi k just means multiples of 2 pi. All right, now I want you to think about this. All right, if I'm at, say, pi over 6, if I add a multiple of 2 pi, let's just say that I added 2 pi to that, where would that put me at? Right. And so the sine or the cosine or the tangent or the cotangent or the secant or the cosecant would be the same. Okay. So if I went around 4 pi, it would still be at the same spot, wouldn't it? All right. So what we're saying here by the 2 pi k idea, 2 pi k just means multiples of 2 pi. Okay. So if I went around the circle multiple times but went back to the same spot, it would equal the same thing, wouldn't it? Okay, so let's see if you can guess what's going to be on this side over here on my equal sign. The sine of x plus or minus 2 pi k. If this is pi over 6, and I say plus or minus 2 pi, or say 8 pi or 10 pi, it's just still going to be pi over 6, isn't it? Okay, so what's it going to be here? X. Okay. Now, So I probably should have wrote those where I'd put cosine or sine x cosine over here. Okay, I kind of wrote them backwards there. So you may want to write that way. It'll make sense better. Now, notice on tangent though that we only just say pi k. So just multiples of pi, not multiples of 2 pi. That goes back to this idea. The period for tangent was only pi instead of 2 pi. Okay. I'll let you catch up a little bit, and then we'll illustrate that one real quick. All right. So now on these two, I want you to think about pi over 6 just a second. Okay. Now, I've got it written out to the side there, but what's obviously the tangent right there? We've probably memorized that. Square root of 3 over 3. Okay. Now, if I added pi to that, give me what's pi in terms of my unit circle, sort of halfway around. Okay. So halfway around would just put me at 7 pi over 6, wouldn't it? Okay. Now, what's the tangent of 7 pi over 6? Square root of 3 over 3. So you get why tangent's a little bit different. All you have to do to get the same value on tangent is only go halfway around. Okay, and that goes back to why the period on tangent and cotangent was just pi. And so that's why on our periodic identities or our periodic properties, it's just x plus or minus multiples of pi and not multiples of 2 pi. So what's going to happen later is when I see this written out, cosine of x plus some even multiple of pi, it's just the same thing as writing cosine x, and it makes things easier. Now, last one's here, and then we're going to start going over review problems, or our cofunctions. Okay, so we've talked about these before. Oh, it should be plus or minus. They were all plus or minus there. What was the minus idea? What would minus do instead of plus as far as on my unit circle? So if we added 2 pi, we would do this, wouldn't we? Yeah, the direction, all right? So if I said subtract a multiple of 2 pi, we would just go around. But we still wind up back at the same spot, okay? All right, let's look at our cofunctions. Okay, now really, I could write six little equations or expressions for this. Really, all 3 of them is all you need. Okay, let's start with a function like sine. What's the cofunction for sine? Cosine. Okay, and then the function for tangent is cotangent. Okay, the cofunction for secant is cosecant. Okay, but let's see, like this first one here. So you got, there goes sine, secant, and tangent. So their cofunctions are cosine, cosecant, and cotangent. But does sine theta always equal cosine theta? What do you have to do to make it equivalent? Right, subtract it from 90. Now I'm going to have it written in radians though. Pi over 2. Okay, because usually once we get past like this test on Tuesday, almost everything is just going to exclusively go to radians. Okay, so that's why I wrote them in radians here. All right, so the shortcut here is this. When I see this written, I'm just going to write that instead, and that's going to be much easier to deal with. Okay, now you'll see how we could flip these around. Would it work here if I just switched these two? Yeah, it would still be true. Okay, so that's why I just say let's just write 3 of them, and that'd be good enough. All right, you have to recall all that on that test, and again, this is just to make sure that you really know these for the last 2 units we're going to do.